Hi everyone, welcome to Engineering Mechanics. We're gonna solve problem on topic equilibrium of rigid bodies in 3D force systems. A 200 mm lever and a 240 mm diameter pulley are welded to the axial BE that is supported by bearing at C and D. If a 720 Newton vertical load is applied at point A, when the lever is horizontal, determine A. the tension in the cord, B. the reactions at C and D. Assume that the bearing D does not exert any thrust. By diagram, we can come to the conclusion that the lever is in horizontal direction and the force of 720 Newton is acting on it. A pulley is 240 mm diameter and it has radius 120 mm radius. Since they are asked to assume that the bearing at D does not exert any axial thrust, that means dz equal to 0. Conditions of equilibrium. For a rigid body to remain in equilibrium in 3 dimensions, the sum of force in x, y, z direction must be equal to 0 and the moment at any point must be equal to 0. To find the tension in the cord and the reaction at C and D, we are taking three equations, that is moment at point C and force in x direction, force in y direction, force in z direction, and equating to 0. So let's find the tension in the cord and the reactions at C and D. Sigma mc equal to 0, that means moment at any point is equal to 0, so moment at point C is also is equal to 0. Moment at point C due to D is equal to 120 into force at D, that is dxi and dyj. Since it is clockward moment, we are taking it as minus, and moment due to tension of the cord is T of I into 120, the radius of the cord and the distance from C, minus the distance from C, that is 160k, plus uh, moment at C due to force of the lever, so that is 80k, that is distance of B and BC minus distance of the lever 200I into 720 Newton force at A. Since it is an clockwise moment, a negative symbol is added. Tension in the cord is an anti-clockwise moment, so no negative symbol is added. So after this we are getting equation minus 120 dx j cap plus 120 dy I cap minus 120 t k cap minus 160 t j cap plus 57.6 into 10 power 3 I cap plus 144 into 10 power 3 k cap. Now we are equating this coefficient equal to 0, that is I, j and k. K is minus 120t plus 144 into 10 power 3. If we equate, there is only one unknown variable, that is t, so we will get the answer. T is equal to 1200. Subdivision A is completed. Now if we take I and solve, 120 dy plus 57.6 plus 10 power 3 equal to 0. Dy By finding this, we get dy equal to minus 480 Newton. If we take the equation along J direction, 120 J 120 dx minus 160 into 1200 equal to 0. Now if we equate this, we will get dx equal to 1600. Now we are taking summation of force at x, y and z direction and equating to 0. Summation of force at x direction is equal to cx plus dx plus t. We know that dx is 1600 and t is 1200, so minus 1200. So we are equating that we will get cx equal to 400 Newton, and similarly we should do for y direction, cy plus dy plus 720. 720 is the force acting vertically downward at point A. Dy, we know that dy is 480 Newton, so 480 plus 720 equal to 1200 Newton. Since no any axial thrust, cx equal to 0. Final answer we will get is tension in the cord T is equal to 1200, reaction at C equal to 400 Newton I cap plus 1200 Newton J cap, and reaction at D equal to minus 1600 I cap minus 480 Newton J cap. Thank you.